Probably.
Right.
I have no sense at all. Thank you.
All right, so I am recording, and I'm going to share my presentation here. Can everybody see the presentation?
Affirmative.
All right. So today we're going to talk about APRS. My name is Jan, KD7ZWV with the Murray Amateur Radio Club, and I've been using APRS for, well, probably more than 10 years now. I've been playing around with it. Unfortunately, there hasn't been a lot of other people that have been using it, so I'd like to see our club get more involved with it. So let's go ahead and get started. What is APRS? So for people who have no idea what APRS is, well, it's an acronym, right? So let's think about what the APRS could stand for. It could be Amateur Position Reporting System. That sounds pretty likely. I think APRS has a lot to do with GPS and position reporting and things like that. Amateur Packet Reporting System, Automatic Packet Reporting System, or Automatic Position Reporting System. What is everybody's vote on that? What do you guys think it stands for?
Amateur Packet Reporting System.
Any other guesses?
I agree. Amateur Packet Reporting System.
All right. Any other guesses? Because you're not right. So any other guesses?
Starts with automatic.
APRS is the Automatic Packet Reporting System. So let's break it down. What's Automatic Packet Reporting System? So automatic, it doesn't need a control operator doing something physically on the radio to make it do its thing. So it's going to automatically send packets periodically. It's what we call beaconing. So you don't have to sit there and key your radio anytime you want it to happen. It's completely automatic once you got it set up. Packet, it uses packet radio protocols. So packet radio, we're going to talk a little bit about that and kind of talk about how that works and what it's all about. Reporting, it's used for disseminating information. So the S stands for system. It's not useful by itself. You need to have multiple radios, computers, networks, people involved with it. Doesn't do you much good if you're sitting there broadcasting out your location or your information if no one is paying attention to it. So you'll note that it doesn't say anything about position. It's because it's not just about position. It does have the ability to report positions, but it's not about position reporting. It has the ability to track vehicles, but it's not about tracking vehicles. It has the ability to tie into the internet to spread information over a wide area, but it's not about wide area usage. APRS is a tactical real-time information distribution system. Let me give you a little background on it. APRS was designed and conceived by Bob Berninga, who is a faculty member at the U.S. Naval Academy in Annapolis, Maryland. And he came up with this idea to leverage packet radio protocols to spread tactical information around. And it's used in a lot of different things. So what can we do with it? Tactical information reporting. So things like, where is that resource? I'm on a bike race and I need to know where the SAG vehicle is that has my extra tires in it for the bike mechanic, right? I can look at my tactical information display and see exactly how far away from me he is, where he's at. What bikes or runners have gone through a particular checkpoint, it can track that information too. If I have somebody sitting at that checkpoint and they are punching in the numbers of the bib numbers of the bikes or runners as they go through, that information can be captured and known throughout the course without having to report it verbally over the air. So what happens when we report something verbally? Sometimes people don't hear what you're saying or they get it wrong. When you're typing it into a computer system, it's very easy to get it right. Let's see, things like, where can I find a local repeater? What frequency is it on? What's the PL tone for that repeater? The APRS system has the ability to send out what we call objects that contain that kind of information. So if you're new to an area, you come into an area where you've never been before, you turn on your radio on APRS and wait about 10 minutes, and you'll have all of the local information about what repeaters are where and what frequencies they're on and what PL tones they're using should all be right there for you to select from. Things like, where is the local ham fest, or how do I get to the local ham fest? Well, that information can be posted with an APRS object. Or where is the local ham club meeting tonight? You notice the key word in a lot of these is local. What local users are on their radios right now? What frequency are they on? How can I talk to them? That's tactical information. It's not strategic information. It's tactical. It's things I need to know about right now while I'm here, while I'm standing in front of the radio or holding the radio. It can also be used for instant messaging, which is like text messages, kind of like your SMS messages on your phone or your IMs on your computer, but it goes over the radio. You can do it station to station. You can do it over a wide area via the internet. And we're going to talk about iGates a little bit later and how things get onto the internet. There is the ability to have a message group. You can have send a message to CQ server and join a particular group, and then anybody who sends anything to that group, you'll get a copy of that message. You can also use it to set up Echolink or IRLP connections. So say I wanted to talk to Bob Berninga, who is in Maryland right now. I can send him an AVRS message over APRS. And what AVRS will do is it will say, okay, I know that you are here and Bob is here, and this Echolink node is close to Bob, and this Echolink node is close to you. So if you tune to this Echolink node and connect to this other Echolink node, you should be able to talk to Bob directly. So that's kind of a cool thing. That's a really cool thing. It can be used for an email gateway. You can actually key in a message on your radio and have it show up in somebody's email box, or vice versa. And it can be used with any device, not just a radio that has APRS built into it, but it can use a protocol called APRS TT or APRS touch tone, which uses the DTMF pad on your radio. I'm not going to talk too much about that because that gets pretty complicated, but I just wanted to mention that it is a possible thing. It's also used for special events like high altitude balloon tracking and telemetry, or any other telemetry. In some areas around the world, they have floods. We don't really have much trouble with that here usually, except for a couple of weeks in the summertime maybe. But it's very easy to set up a radio at some location with a water depth meter attached to it that periodically sends out or beacons out that water depth, and then you can see if the water is rising very rapidly and take appropriate action. Or people will have their weather stations attached to the APRS radios, and they actually send out weather information on a dynamic basis. So if you want to know what temperature it is over on the other side of town, or what the wind is blowing at somewhere, you can pull that up on your APRS radio. How does it work? So it uses packet radio technology, and yes, packet radio technology has been around since the 80s, maybe even a little bit before the 80s. I think some people were playing with it as early as the 70s. But basically, you would use a computer, a TNC, which is a terminal node controller, works kind of like a modem, and a radio. So you would have your computer connected to your TNC, connected to your radio, and you can see how old this is because he's got a giant power supply underneath his little radio there, and his antenna is tiny. So he can't be anything like we were talking about earlier, Dan, with our extra long APRS antennas. So, so basically the computer or terminal connects to the TNC using a serial connection. The TNC connects to the radio using an audio connection, so it connects to the radio speaker and microphone and the push to talk button on the radio. And so the TNC can key the radio up, send out a signal, an audio signal, and then release a PTT and listen for responses. So the TNC manages that connectivity, and then it translates what it gets back, just like a modem would do, translates it into digital or ASCII type text and sends it back to your computer or your terminal. So it can be used, move my little window down here so I can see the right side. So here's an example, station-to-station message passing. This is a little network that was set up in California where they had several machines talking to each other, and it uses this AX25 protocol on the air. And then you can see at the top center of this, there was actually an AMSAT Oscar 10 satellite that was part of this network. So even though one guy was in Menlo Park, he could talk to someone in Redondo Beach utilizing the satellite. Sorry, we got a helicopter going over here. Give me a minute to go by. Heroes of living close to the hospital is you get to hear the helicopters go by a lot. So you can see that some of these stations would route their communications through one or more other station to get to each other. So you'd have to know like who was where and how to communicate back and forth with them. So packet radio is used for things like bulletin boards. If you guys remember the old BBS systems on computers where you would dial in, they actually had bulletin boards on the air as well using this packet radio communication. You could do station-to-station chat where you could type text back and forth with the other station. You could do email over it. This is just an example of an application called WinPack that shows some traffic going back and forth on the packet radio. APRS uses kind of a fake packet destination. So in packet radio, I would say I want to talk to N7XDL, for example, and I would put N7XDL as my destination for my packet. And the intervening digipeaters would figure out how to get from where I am to where he is to deliver that packet. With APRS, it doesn't quite work that way. There's a generic fake address that is the destination of the packet. And I'm going to talk about that in a minute with some examples. But it also includes things like a path, which controls how far the packet can go around the network. And encodes specific information in the message body that contain things like the position of your station, the type of your station, what frequency you're monitoring, any telemetry or weather data, anything like that. So there are these, this concept of digipeaters, kind of like a repeater, where the digipeater will receive a inbound packet and then it will send it back out again. So it's kind of like a store and forward repeater. It's not like a regular voice repeater that we would use where it's transmitting at the same time as it's receiving. The digipeater would actually receive it, examine the packet, and then send it out again. It uses a concept called I-gates, which are used to route local radio frequency traffic in or out of the internet system where there are APRS nodes on the internet. Let's call it APRS-IS. And so you can gateway those packets in and out of the internet. So if I'm like here and I want to send a message to Bob in Maryland, for example, I don't have to have direct radio links between here and there. You can trust that the internet will get it from one place to the other. We'll talk a little bit more about APRS on the internet in a little while. The other part of the message is the path which should be used. And back in the early days, they used the path like relay, wide, or trace. Those are now obsolete. So if you ever find any APRS equipment that's configured to still use relay, you should tell the owner not to use that anymore. Since about 2003, we've been using the so-called new path paradigm. And what the new path paradigm does is it says, I'm going to send markers that show like how far I expect this packet to travel or how many hops I expect it to take. So if you look at my examples here, mobile should typically be set to wide 1.1, wide 2.1. What that means is that the first station that receives it will say, oh, this is wide 2. I'm going to look at that. And the -1 says it's already been 1 hop. So I'm going to decrement that and I'm going to send it out again. But I'm going to take that wide 2 off because it's now 2-0, right? And so the next station that receives it will see wide 1.1 and it will say, okay, I can resend it 1 additional hop. And it'll do that, but it'll take that off. For fixed stations, this, I don't know why this showed up this way, but it should have been wide 2-2, not wide -2. I should fix that in my slide. But for fixed stations, this is basically saying it can go 2 hops between stations that are configured for wide 2. There's also the concept of a statewide path, which is a 2-letter state designator. We call it SS N-N. So here in Utah, we would use something like UT6-6, and that says you can basically go up to 6 hops in any direction, but don't leave the state of Utah, for example. The reason that's not so terrific out here in the West, but if you're somewhere like Maryland, if you're using a path of 6-6, you might be hitting 12 different states. Whereas if you want to keep it localized to your state, you can do that by using the state path. And then there's also this concept of a temporary path, or temp N-N, which you can use for what they call fill-in digis or temporary digipeaters. For example, if you are out hiking somewhere, you want to set your mobile radio up to be a fill-in digipeater because your handheld won't reach very far. Your handheld can reach your mobile from wherever you're hiking to, but it won't necessarily reach one of the big digipeaters up on the mountains. So you would set up that temporary path specific for that. It's also used typically for things like hamventions or field day or things like that, where you want to keep your traffic more localized.
Before you go on,
Yes.
I have a question.
Yes.
On the mobiles, well, actually, just on the recommended path, as you might recall, last week we were trying to deal with the Yaesu
Yes.
version of trying to do this. Yeah, and mine was set to P3.
Did you figure out what that meant?
Yeah, well, I actually went into edit P3, and it actually was wide 1-1, comma wide 2-1.
Oh, it was. Okay.
Yeah, so that's why they say do P3. But
That's
I
it.
had up to like 6 other ones that I could have used, custom ones. So if I were to change it to wide 1-2 and wide 2-3, I can control how many hops it is taking, correct?
Correct. You can control how many hops it's taking. You would set it to like wide 3-2 or something like that, or wide 2-2 or 2-1.
Yeah. Okay.
So yeah, the number at the end is the one that gets decremented, and when it goes to 0, then that path element goes away. Is the way that it works.
Sure. Okay.
So, but yeah, you can. So that's an advantage on those Yaesus, is you can set up several different paths for that you might want to use. So maybe if you're in one particular location, you use the standard wide 1-1, wide 2-1 setting. But if you're out in the boonies somewhere, you might need to go to wide 2-2 or wide 3-1 or something like that to get your packets out of where you're at and all the way into an iGate. So you could set up a separate P setting for that and then quickly change from one to the other without having to reset your entire path. So that's kind of a cool feature.
Thank you.
And that does make sense that was doing that. So I was trying to figure out what you said it was on P3, and I'm thinking, well, is that set for 3 hops, or is that set, how is that set up? But it does make sense that it would be set to a specific path.
Sure.
So it's like a placeholder for a path.
Yep.
All right, so these are recommended frequency settings for APRS. Here in the US, we have a nationwide APRS frequency of 144.39. Other regions have different settings. The APRS is a worldwide system, but other nations do use a different frequency as their nationwide frequency. There's a whole list of them online, and I didn't put them all in the presentation because we're pretty much all local here. So in the US, we use 144.39, and the recommendation is to set up about 5 channels on your radio for APRS. So your channel 1 would be your APRS raw channel, and that's set up with no tone. Basically, when you're set to the APRS raw, you're going to be listening to everything that's going. I'm going to put my radio on raw right now, and we'll wait for some traffic to come through so you can hear what it sounds like. So there were 2 packets right there, and a third. So you can tell that that's going to get really annoying after a while. So you don't normally leave your radio set to that. And a lot of times what people would do is they would they would turn their volume down, which is fine, but then they would forget that they had their volume turned down, and they wouldn't remember to turn it back up when they needed to. And so they would be always wondering, am I receiving anything? Am I getting it? I don't hear anything, but they're not hearing it because they have the volume turned down. So Bob came up with this concept of voice alert, and I'm going to talk a little bit more about that in a minute. But the normal APRS operation frequency would be that same 144.39, but you set a CTCSS code or a tone of 100 hertz. And that would be the place that you would normally leave your radio. Now, if you happen to be in an area that's really dense with other operators who are using voice alert, and again, I'm going to talk about voice alert in a minute, it might be too noisy for you even at that. So you have a third frequency, the APRS mute frequency, that has a DCS setting. And DCS is a digital carrier squelch. And we don't normally talk about DCS very much. We talk about CTCSS a lot. That's the subaudible tone. What DCS does is it actually sends out a digitally coded number. And so you can pick your own number. And what I have mine set to on my APRS mute is, let me look here and see where I have that set. I have mine set to 054. So think of that as kind of like a privacy code or a don't bother me code. If somebody knows your code, they can still send you a voice alert. Even if you're in APRS mute, you'll still hear them. But if they don't know your code or they don't happen to pick the particular code you want, that's why we use DCS instead of CTCSS, is it's harder to guess. There are more of them. But then your radio would be silent pretty much all the time, even with your volume turned up. The other two are the APRS input and APRS digi. With APR input, you're going to set up your radio on 144.39, but you're going to set it as though it were a repeater with a plus 600 offset. And so the way that works is at an event, you might have a digipeater that is listening on 144.99, which is the 600 kilohertz offset. And so you can see frequency number 5 is the APRS digi, which is 144.99. And so the way you would set that up is that way you're not flooding your 144.39 with a lot of packets or a lot of calls that are going to be repeated all the time, right? So essentially, if you think about it, with the digipeater, anytime I send a packet, my packet goes out, and then the digipeater sends it out again. So it's used up twice as much bandwidth on this channel as it would if I was on just sending it without a digipeater. So the idea is that everybody transmits on 144.99 and receives on 144.39, and so you only hear the digipeater. The digipeater hears everything on the 144.99. So it's just kind of a setting to help reduce the congestion on that channel. Typically, those will be used for a temporary event. And I wrote down on here wide 11 digi, but I really should have put temp 11 digi, because that would be more in line with an event setting.
So
yes.
Before you go, I have a question.
Yes.
Turn back. So are you telling us that as a club, we could all do APRS mute and do a DCS code of 022 or whatever we choose, and so that when we send messages, we'll only hear our club stuff and we won't hear the stuff that goes out simplex?
Not exactly. I'm going to talk a little bit more about the voice alert in a minute here, and that's where this comes in. So
Okay.
So in fact, I think it's on the next slide.
I'll hold off.
Okay, so I'm going to go ahead and move on here. So voice alert, you heard me say voice alert several times now. What does that mean? So the idea is you set your radio to the CTCSS 100 hertz, and then you'll only hear other stations that also have voice alert set up and are within simplex range. So if you happen to be driving down the freeway with your radio set up like this, and you hear an APRS packet come through, then you'll know that there's another station out there that is within simplex range of you. You can hear them, so they should be able to hear you, right? So you can quickly make a voice call on the APRS frequency. Again, you'll be using that CTCSS 100 hertz tone on your voice call, so that receiving station should hear it, and tell them, hey, APRS voice alert, QSY to whatever, 146.52 or whatever, right? And then you could switch over to that frequency and have a conversation. So that's a way that you can find somebody local to you without having to know their frequency already. Because everybody's going to be monitoring the APRS frequency. It's a national frequency. It's always the same. So if you hear an APRS packet, even though you have your CTCSS set, your voice alert code set, then you will know that they are also using voice alert, and they should be able to hear you give a voice call. Now, to go back to what you said, Dan, if we all in the club set our DCS, our APRS mute to the same DCS number, then we would not hear other voice alert stations, but we would hear any other club station that was also using that same code. So you would know if there was somebody else in the club who was within simplex range of you. So
Okay, and I bring this up because during our Utah SAG events, where we use APRS, you know, everything is just set to raw, and
Right.
you know, I'm hearing everybody, and so is net control. So seems to me this is a better, more elegant solution.
yes, rather than turning your volume down, this is definitely a better solution, right? Now, the normal APRS traffic won't be affected by this voice alert setting at all, because your TNC is actually listening to the signal before the squelch gets a hold of it, right? So remember what CTCSS stands for is continuous tone coded squelch. I don't remember what the other S is for, but basically your radio doesn't open the squelch unless it hears the tone. But because your TNC is connected prior to the I guess amplifier or the speaker or whatever you would call it, it actually hears all of the radio traffic anyway, even though it's not using that tone. So your TNC is still going to hear all the traffic, but you don't have to sit and listen to all the traffic, right? So you don't have to sit there with your radio humming away and squealing and squawking all the time and wondering what in the world's going on. You, rather than turning your volume down, you can leave your volume turned up, and then with the voice alert, you hear, if you hear somebody, you know that they're within simplex range. And again, if you hear too many somebodies that are within simplex range, like you're at a hamvention or something and everybody's got voice alert turned on, flip it over to APRS mute, and you will only hear people who have chosen the same DCS code as you. Excuse me.
Excuse me on this. Did the national parks out here in the West set that up, or did we have it set up for the national parks there a few years ago like that?
I don't know how they had it set up. I wasn't involved with that, but voice alert has been a thing. Oh, I can't remember when Bob came up with the idea, but it's been a thing for many years. And in fact, the newer radios like my Kenwood D72 actually have a voice alert setting that I can turn on voice alert on the radio, and it will automatically select that 100 hertz CTCSS tone. I don't have to make that setting by hand. So
what's to prevent you from, as a club, going to 127.3 hertz? We could do that, and it would be just the same.
Yeah, that would be just fine. You could use whatever CTCSS you want. There is a standard though of using the 100 hertz, because that, you know, is for voice alert. It's standard, basically worldwide. So if you're like traveling around somewhere and you have your radio on with voice alert set up, you will hear somebody local. And really, communicating with people is about talking to somebody local, right? If you want to know where the nearest good fishing spot is, it's not going to help you if you're talking to someone 3,000 miles away. You want to be talking to somebody local. You want to get local information. And again, APRS is all about tactical or local information. It's not all about the long distance stuff. It can do the long distance stuff, but it's not all about that. So the idea being, set up voice alert on your radio or set it on that APRS mute channel. If you're hearing too much noise, don't turn your volume down, because if you turn your volume down, you might forget that you had it turned down and you'll be wondering why you're not hearing anything. So a lot of people didn't understand this when voice alert was still first starting to be a thing. And so there's quite a few people out there who have made presentations about how to set that up. You can find some of those on YouTube, I'm sure. So But it's kind of a clever idea to, let you be aware of other stations that are within simplex range of you. So kind of a cool thing.
Well, on my radios, I'm sure we can have a setup to where we can limit the distance that we receive a message from, like 100 miles or 50 miles or 400 miles.
So with APRS, yeah, you can set a range of stations that you are interested in that would have to be within that range for them to show up on your display. But that's outside of the physical radio propagation capabilities. So because you'll still see that if you set it for like a 50-mile radius, you'll still see stations within 50 miles of you, even if they have to go through 2 or 3 digipeaters to get to you.
Right.
All right, so let's move on. So one thing that we talked about last week a little bit on our experimentation session was the SSID. And basically what this lets you do, since your call sign is basically your identifier on APRS, this lets you specify multiple stations with your same call sign. So typically your -0 SSID, or the missing SSID if you don't include it, is going to be your primary station. It's usually a fixed station. It's usually capable of messaging. The -1 through -4 would be a generic additional station. Could be a digipeater, could be a mobile radio, could be a weather station or whatever. -5 would be like other networks. So D-Star, iPhones, Androids, Blackberries, things like that. -6 would be used for special activity like satellite operations or 6 meters or something like that, something different from normal. -7 is typically used for HTs or other human portable radios. -8 would be boats, sailboats, RVs, or a secondary main mobile radio. -9 would be your primary mobile. That's usually message capable. -10 would be an internet station, so iGates, Echolink, WinLink stations, APRS, APRN. We haven't talked about APRN, and I don't think I talk about that anywhere actually in this presentation, so I'm not sure why I put it in there. But okay, never mind. -11 could be balloons, aircraft, spacecraft, things like that. 12 would be APRS touch tone. And again, I mentioned that before, but I'm not going to really go into it in depth. There's also RFID markers, devices, one-way trackers, things like that. -13 is reserved for weather stations. -14 is typically used for truckers or full-time drivers of some kind. -15 is a generic additional station. So back in the early days of APRS, this number, this SSID number, secondary station identifier number, was actually used to specify which symbol would be seen on the map for your station. Nowadays that has changed, and they now have multiple symbols that can be used. And so these are just a few examples of some of the symbols that can be used. So you can see PD would be a police department. The little telephone handset would indicate you're on a phone. The little car with the antenna would be your little mobile car. There's a tent for your campsite. WX would be a weather station. There's a little icon for your house, for your home station. Various different icons. There's a train. There's a satellite dish. People have put trackers on their dogs before and actually monitored their dog's position with that. So there's a little dog icon that could be used. And then the alternate symbols, that shows a bunch of different ones. And you can see some of them are basically a generic plus or cross symbol. And some of those have actually been modified now to support numeric or alpha overlays, where you might see like a 1 on top of that, or a 2 or something like that, to indicate that that is your digipeater number 1 or something like that. We'll see some of those when we get to our example, our demo, which will be towards the end of the presentation. Okay, so here's some example APRS traffic. And so I kind of broken this out. This is some traffic that I recorded on Monday when we had our practice session. So several of us got together, several of us that have APRS capable radios got together on Monday and played around with it for a little while and sent some messages back and forth. And so I recorded some of that traffic. And so you can see here kind of what the messages look like. And I'm gonna break some of these down so we have an understanding of what's actually going on in here. So here's an example of a message that I sent to Gordon. Excuse me. So you can see the timestamp of the message. The source station or sending station is my station, KD7ZWV-3. This was sent from my laptop using Mobile Link DTNC and my Baofeng radio. The destination is APJYC1. And so this is kind of what I was talking about with that fake, what they call a two call. And so the APJY indicates that this is a YAC station, which is yet another APRS client. And so that just tells what kind of software I was using when I sent this packet out. And then you can see it also shows the wide 1-1, wide 2-1 path. And then it shows the type of the packet as APRS. And then the message includes the recipient, which is Gordon's call sign, KE7LWV-9. And then the message itself, hello, Gordon. And then the little curly brace and the C0002 is a sequence number for that message. So whenever I send a message, not a beacon, but a message, my radio is going to put, or my software is going to put a sequence number on there so that I can identify that message. And then shortly thereafter, so that went out at 7/17/16, and at 7/17/25, I received a reply from Gordon. So you can see the sending station was Gordon's call sign, KE7LWV-9. His was a APY 100, which is a Yaesu FTM 100, which is the radio that he was using. Again, there's the same path, wide 1-1, wide 2-1, and APRS. And then his message came back to my call sign, and it was AC C0002. So his radio sent that automatically, and it was an acknowledgement of my message C0002. So it was acknowledging C0002. And that way my radio knows, oh, he received it. So if it didn't see that message come back, it's going to resend my original message several times to try to make it go through.
Like a TCP message.
Kind of like a TCP message, yeah. Only it's using AX25 and packet radio protocols.
Cool.
So it's pretty slick. So let's look at another one. So this is just another breakdown of the message itself. So the message text was, on my message, it was Gordon's call sign. Hello, Gordon was my text message, and then the sequence number. And then his response came back to my call sign with AC and the sequence number. So let's look at another one here. So this one was the sending station was LGU, or the source of the object was LGU. The message was a beacon type, so it was something that was sent out automatically. KF6RAL-2 is the digipeater that actually sent it. So this was a beacon packet from KF6RAL-2. The name of the object is 147.620 UT, or U rather. So what that is the frequency. It looks like a frequency, right? It's actually a repeater object. So it's telling me that, hey, there's a repeater at 147.26. This 111111Z is a timestamp, and it's a special timestamp that basically says this object doesn't expire. And then there's the code here that starts with 4117.75N. That's the latitude of the object, 41 degrees, 17.75 minutes north. And then 11228.09 west, 112 degrees, 28 minutes, 9 seconds, or 28.09 minutes west longitude. And then the text attached to the object is a frequency, 147.26. The tone is 103 hertz. And the radius or range of that object, or the altitude of that object, is 95 meters. So this is on top of a mountain somewhere, probably. And then there's also some explanatory text after that that says, hey, there's a net on this repeater every Tuesday night at 9 p.m. And there's a meeting on the second Saturday of the month. So if I was somebody who just came into Utah, didn't know anybody, didn't know where anything was, now I know that there's a net on Tuesday at 9 p.m. on 147.26, and this is the tone I need to use. So I can tune my radio to that and hop on a net and meet some people. So it's kind of a cool feature. Let's see, here's another one. This is being sent by a Digipeater N7BYU-1. So its to call is APN 391, which is a Cantronics KPC3 with ROM version 9.1. Cantronics is a type of TNC, and we'll talk about that in a minute. And then it was sent via KF6RAL-2, and the star indicates that that was the last station that handled it before it came to me. And it still had wide 2-1 in its path. So other path entries had been removed by that point. Then it has, again, its position, 40 degrees, 14.91 minutes north, 111 degrees, 38.83 minutes west. And then this PHG is the power height gain value. And there's a way to decode that. I'm not sure what it is. I've never really paid that much attention to it, but it's something that indicates how much power the radio is using, how high the antenna is, and if there's any additional gain on the antenna. So we can look that up and figure out what 8330 means, but it's something that I haven't specifically decoded. So that's just some examples of some APRS traffic. So what do I need if I want to play APRS? Well, you need a radio, a computer, a terminal, a TNC, or you need a radio with a built-in TNC, or you need internet access and a website. And so we're going to talk about each of those. So for radios, you need a radio that'll do 2 meters, because the national APRS frequency is 144.39 megahertz, which is in the 2 meter band. So you want a radio that'll do 2 meters. If you get a radio that has a data port, that makes connecting it up to a TNC a lot easier, because the data port will give you that pre-discriminator, pre-squelch signal. Excuse me. Give you that pre-squelch signal and allow the TNC to activate the PTT on the radio to send traffic. So what that typically looks like is it's typically one of these DIN 6 connectors. It could be a different type of connector. It could be a DB9 or DE9 or something like that. But typically it's going to be one of these DIN 6 connectors. And the pinouts are typically transmit audio on pin 1, PTT on pin 3, receiving audio at 1200 baud on pin 5, receiving audio for 9600 baud on pin 4. The difference between these is there might be some bias that is not present on the 9600 baud, but is present on the 1200 baud. And then an indicator that says if the squelch is open or not. And then, of course, a ground for that connection to the radio. So if you don't happen to have a radio that has a data port, you can connect it to the microphone and speaker connections on the radio. So that's, in fact, when I connect it to my Baofeng, because my Baofeng is just a little handheld, I have, let me show you, if you guys can see in the picture of me, I'll show this more when I do the demo, but this is basically my TNC, and it has a little connector here that plugs into the headphone speaker mic jack on my radio. So so for a TNC, there's a lot of different things to choose from. There's the Cantronics KPC series. Those are pretty expensive, but they've been around for a long time. They seem to work fairly well. Argent Data produced a device called the Open Tracker and Tracker 2. That's this one on the second one over here. And then the Bionics company produced a thing called the Tiny Track. They've had several different variants of that. I think the current one is the Tiny Track 4, which I have a picture of here. The MFJ TNCX. So there was originally a guy who started putting together these things called the TNCX that were, you basically would send you a kit. So you would order it from him, and it came as a kit with a bunch of components, and you put it together yourself. And that was the TNC-X. He is no longer making those, but MFJ has picked those up, and they are still manufacturing and selling the TNC-X. So they sell it in a nice case with the appropriate cables that you can order and everything. The MobiLink D, they have a couple of products, the TNC2, which I have, and this is a picture of the TNC3. If you're using an Apple device, like an iPhone or something like that, you want to pick up the TNC3. Also, if you're trying to do WinLink over your TNC with PC, you'd want the TNC3, not the TNC2, if you're using Windows. And also, the West Valley City ARC is producing, that's the local amateur radio club in West Valley City. They are producing a device called the TNC Pi 9K6, which is a little board that plugs into your Raspberry Pi computer, and it just plugs directly on top of it like a little daughter board on top of the main Raspberry Pi board, and it provides a full TNC with 1200 and 9600 baud capability. So it has connectors that let you connect that up to your radio.
I will say that is what I use, and it comes as a kit, so you put it together.
It does come as a kit. I think you can get it pre-assembled if you pay extra.
Yep, that is true.
But if you're comfortable with a soldering iron, then go for the kit and get some experience with that. It's pretty cool. There's also, you can use a software TNC, in which case you would need some kind of an interface to connect your radio's audio connection or speaker and microphone connection to the sound card on your PC. And then you'd run some software on your PC. There's Direwolf and Sound Modem, among others, that you would run that software directly on your PC, and then that would act as the TNC of the terminal node controller. So a lot of people do that. A lot of people who are doing like, PK8, PKS31, things like that on HF already have a device called a Signal Link that hooks up via USB to their computer and then hooks up to the speaker and mic ports on their radio. And so they could use that to do APRS from their computer using one of these software TNCs. Then you could look at a radio that has a built-in TNC. So Kenwood sells a few different ones. The THD7 is no longer for sale, but some people, Ragnar, still have them. And this was like the first handheld radio with a TNC built into it. And it's actually, when I was looking at buying my first radio, I seriously considered buying one of those, but I ended up going with the F6A instead, because the D7 used NiCad batteries, and NiCad batteries have a history of developing strange problems and needing to be fiddled with a lot. So I wanted to go with something that had a lithium battery in it. But they also have come out with the THD72, which is the one in the middle here. That's the radio that I have, and it actually has a GPS built into it. It has, the full APRS capabilities. You can hook it up to your computer with a USB cable, and it's a very handy little device. And then lately, just recently, they came out with the THD74, and I know Neil has one of those that also has full APRS capabilities and has, a full display and everything right there on the radio. And it has a bunch of other new cool features as well. Plus it does 220 megahertz as well. So that's kind of cool. As far as mobiles, the original mobile from Kenwood was the TMD 700. And I think Ragnar said he has one of those as well. And then
radio.
And then the new one is the D710. And in fact, there's now what they call a D710G that has the GPS built into it as well. So the GPS is actually inside the head unit, and you don't even have to add a separate GPS unit to it.
Station 83 has that.
They have a D710?
Yes.
Okay. So I'm not sure how that would work in the basement with picking up GPS, but I don't know how much that matters. If it's a fixed station, they're just going to hard code a latitude and longitude anyway. So that's from Kenwood. Yaesu also has a few offerings that have built-in TNC. Yaesu has gone a slightly different route in that they don't allow you direct access to the TNC. So you can do the APRS stuff with these radios, but you can't do generic packet radio stuff with them like you can with the Kenwoods. So that's something to consider. Their APRS implementation is very good, though. The VX8 is a handheld. Dan has the FT2. I think the FT3 also has APRS built in, and those are actually digital radios that can do what is it? Fusion, isn't it? Fusion for Yaesu.
That's correct.
And then the FTM 100 and 350 and 400, they also have that capability. And if we remember from our example packet, Gordon has the FTM 100. So those have APRS built into them as well. And I suspect that there are other manufacturers that have them. I don't know of any others, but for example, I haven't heard of any ICOMs that are specifically set up for APRS, but the D-Star radios I think can do APRS over D-Star. So I'd have to look into that for more information, but there are other radios out there that also have APRS built in. As far as computer software, I have a package called Yak that I have on my Macintosh that uses Java. It's very portable. It'll run on anything that Java will run on. So Windows, Macintosh, Linux, whatever you want, Yak will run on it. There's also a package called Xaster that is specifically for X Windows that Linux users have been able to use. For Windows, a really good system is APRS-IS/CE32, and that's a terrible name, but it's actually really good software. A guy named Lynn Deffenbaugh has created that, and it works really quite well. For Android users with your cell phone or your tablets, there's a package called APRS Droid that you can get. You can download it directly from aprsdroid.org, or if you want to support the author, you can purchase it from the Google Play Store. And for Apple devices that use iOS, like your iPads or iPhones, there is an APRS.fi app that you can install, and I think it's about $7 for that. That's actually produced by the same guy who runs the APRS.fi website, and we're going to talk about that in a minute. So I mentioned a computer with web access. This is a picture of the Salt Lake Valley from about, hour and a half ago, maybe 2 hours ago, that is on the APRS.fi website. .fi is Finland, and the owner and operator of this site, Hesu, he is a Finn and lives in Finland and runs the site from there. But it's, again, worldwide, so you can pick up everything that's running right here. Now, if you look on this picture, you can see, I don't know, can you guys see my mouse moving, or is that something
Yes.
that only I can see?
No, we can see it.
Okay, so I'm circling this little X here. That is the icon that is typically used by an Xaster station. These ones that have WX, those are typically weather stations. You can see out here this diamond with a big D in it. That's a digipeater out here on top of a mountain somewhere. You can see another digipeater here. There's another one there and another one there. And you can also see the track of this one particular station over here. So this is actually showing where he was historically. So as he was traveling down I-15, it looks like, or down Redwood Road, it looks like, and then he got off and went around over here by the lake, and then came down in this direction. That's where I stopped picking him up. But so you can see this information is live through the APRS-IS using APRS.fi. So pretty cool. So what else is there? There's ARISS, which is APRS on the International Space Station. There's actually a radio. It's a D710 on the International Space Station that is acting as a digipeater, and you can actually send packets through the satellite, through the space station to other stations. There are also some PC satellites. There's originally there was Oscar 10, I think, had it, and there have been several different amateur radio satellites that have had APRS capability. Bob Berninga is very involved in these small satellites. That's one of the things that he teaches about at the Naval Academy. And so he often comes out here to Utah for the small satellite conference up at Utah State University, which they have every year. So he's been involved with getting APRS gear into some of the little CubeSats and other satellites that have been sent up into space. So that's kind of cool that you can do that. So even if you're way out in the middle of nowhere, as long as the ISS is passing over, you can probably hit it with a packet and get your message out to somebody. So a lot of fun.
So do you have a location, a website or something that we could go to that talks about more about the satellite APRS?
So I don't have a link to that handy, but if you Google for APRS and satellite, you'll find plenty of information.
I'd rather have it handed to me, please.
Yeah, well, good luck with that. So there's also APRS on 30 meters. So that's an HF frequency. And you can see that there are people using that in multiple countries. So there are several different frequencies that are in use. Typical 10.14760, that's used by a lot of people, upper sideband. It's an FSK protocol on that. But so you can do APRS over 30 meters that covers a very long distance. One of the rules is no digipeaters on 30 meters because 30 meters is a long range radio band. So you don't need digipeaters to get your signal out. Let's see. And I have a space here for a live demo. So I'm going to stop sharing the presentation for a minute. And I'm going to start sharing this. So this is a picture of APRS.5 right now. And you can see right here, I'm going to zoom in a little bit. See that little dude running right there? That's me at my house. So if I click on that guy, you can see that the last packet that went out was at 7:24:23, which was not quite 10 minutes ago, so I'm about due for another one. It shows that I'm monitoring 147.160 megahertz. That is the Ensign Peak repeater, and it's at tone 127. Mike E is a protocol that encodes messages to make them shorter. So we can actually look at the raw traffic, and I will do that in just a second. So I'm going to pull up the info here, and you can see stations that are currently near me. So these are stations that are near me. There's N7XDL-7. He's 2 miles away at a bearing of 108 degrees. So, Dan, we're only 2 miles apart. Let's see. You can see stations which heard me directly. So Shepherd is a digipeater and KF6RAL-2 is a digipeater. They both heard me directly, so without having to go through a separate digipeater to get to them. And you can see some information about where I'm at. I think there's a way to see the raw packet data as well. I don't see it handy though. Oh well, we'll worry about that another time. But you can see here, if I mouse over my station, you can see that it shows a little line going out here to KF6RAL-2. And then there's a second line that goes from KF6-RAL-2 up. Let's see if we can make that go away. There's a second line that goes, well, it goes quite a ways. Let's see. I want to show, so up here, where that line terminates, that's where the iGate is that actually gated my signal onto the internet. So even though this digipeater is on top of a mountain, it's not connected directly to the internet, but it was happy to rebroadcast my packet and send it, and another station way up here actually received it and gated it onto the internet for me so that it could show up on APRS.5. And so if you look, I'm going to actually filter this a little bit. There's a filter capability. These guys, filter. If I switch this to APRS only, that should make the weather stations go away. There we go. So you can see, I'm going to actually make the digipeters go away too. Maybe. Yeah, I don't know if that did what I wanted. I'll just leave it like that. So you can see how many stations there are just around Salt Lake or around Utah. Let me zoom in a little bit again here. And again, you can see like this guy, it shows his track or where his positions were. So he started out here by the airport and came
It
across
went
this
right
way.
by me.
Yep, went right past you.
Holy moly.
That's
what that was.
So if you zoom this way out, it actually goes to a heat map because there's too much information to show. And so the heat map gives you kind of a view of how dense the APRS activity is in the area where you're at. And so you can see over here on the East Coast, it's like really dense. There's a lot of stuff going on with APRS over there.
They use the same map for the coronavirus.
With probably the same amount of propagation as far
Yeah,
as,
I mean,
you know, where the virus is, right? But yeah, so you can see, you know, there are some places up in Montana where you're not gonna be reaching out to very many people. So just keep that in mind. There's got to be somebody there to listen to you. So, but that gives you an idea of how widespread APRS is, especially around Utah. And a lot of the guys in Logan, the Cache Valley area, they use it pretty heavily. Let's zoom in up there for a minute. I want to show you some stuff up there. So one of the things that you have are, if I can find one. So here's a Digipeater AC70A. I'm trying to find a regular repeater. There we go. So this is a repeater object, 146.72. That's the frequency of the repeater. And it shows here that it's on tone 103. And what I can do with my radio, if I happen to be up in that area, I can show you. Let me turn this off for a minute and go back to my picture here. So this is my radio, and you can see sort of that it's monitoring the APRS and the enzyme peak. And what I can do is I can bring up a list of stations. So here's a list. I don't know if this is showing up very well, but
Yeah, we can see it.
there's a list of stations that I've heard. And if I go into one of these guys, let's see. I want to find one that actually shows it. Let's see. Oh, I've got one on here. There's one. So this one is a repeater object. You can see that it has a repeater frequency. And what I can do with my radio is I can hit menu on this. And if I hit menu, you see where it says tune. If I hit OK on that, it'll tune my radio to that repeater frequency and set up the tone and everything for me. So I don't have to punch it in manually if I don't know it. So if I go like when I travel, if I take my radio when I go like to California or somewhere, and I don't know the repeaters that are around necessarily, I can actually have that come up on the list on my radio and see, oh, look, there it is. There's a repeater. I can tune to it automatically and find somebody to talk to. And that is about all I have, guys. So I have a slot for Q&A. If anybody has any questions, I have some resources on here that you can go to for more information. I'll warn you in advance that APRS.org is Bob's website, and it looks like it was made in the 50s. So, you know, be advised that it's going to be pretty scary looking if you're used to modern day websites, but there's a ton of information on there. So, plus Google is your friend for looking for anything related to APRS. If you're trying to remember something and you think, well, it was APRS, it was voice alert, so I'm going to Google for APRS voice alert, and you'll find a lot of good information about it. But if you have any other questions, fire away. No questions?
I have a comment.
I hear a lot of silence. Go ahead with your comment, Dan.
I thought that was one of the most excellent presentations on APRS I've ever seen. Thank you.
My head's getting big. Look out. Stand back.
Explode!
All right.
Oh, thank you. That was awesome. I learned a lot.
I'm going to stop sharing and I'm going to stop recording, and then you can fill me with